Here's a really quick thermodynamics problem which looks at a Carnot cycle. And this is actually a classic question in the sense that we have to look at the efficiency of a Carnot cycle and try to improve it in one of two ways. So, as you know, the efficiency of a Carnot cycle is given by 1 minus T cold over T hot. And we have two ways of trying to improve this efficiency. So in order to increase this eta value, in other words, if we try to get this as close to 1 as possible, we would have to make this part as small as possible, right? Because it has a minus in front of it, so we want the efficiency to approach 1 as much as possible. And we have two ways of decreasing this fraction. One way is to decrease the value of the cold temperature, or we can increase the value of the hot temperature. And both of those ways will actually improve the efficiency by decreasing the value of the fraction. So here's what the question says. You can either decrease the Tc by an amount delta T, or you can increase TH by the same amount delta T. And the question is pretty simple. Which way gives a better efficiency in the end? So this is what we're going to try to look at. So the way I would do this is I would say that, let's call this eta 1, which is 1 minus T cold minus delta T over TH. So basically I'm saying that my first the efficiency of the new Carnot cycle is going to be when I decrease the cold temperature by an amount delta T. And then I'll compare this with the case when I keep the cold temperature constant, but I increase the hot temperature by the same amount delta T. So now we just have to figure out which of those efficiency is bigger. And from this point onwards, it's just a math problem. So I'll say, okay, let's assume that eta 1 is greater than eta 2. You can do it the other way around, and the only reason I'm doing this assumption is to be able to create this inequality. So let's write eta 1. So eta 1 was 1 minus T cold minus delta T over T hot. And let's check if this is actually greater than 1 minus T cold over T hot plus delta T. So we can subtract 1 from both sides. So this is going to be minus T cold minus delta T over TH. And that's greater than minus T cold over TH plus delta T. And now to get rid of the minus signs, we can multiply by minus 1. But because it's an inequality, when we multiply by minus 1, we have to swap the... so from greater than, it's going to become less than. So we have this less than T cold over T hot plus delta T. Okay, so at this point, we can just cross multiply. Okay, so if we cross multiply, because all terms are at this point positive, cross multiplication would give us that T cold minus delta T. So I'm just doing this and this. So T cold minus delta T times T cold times T times TH plus delta T is less than T cold T hot. So this is what we're going to try and compare. So if we expand the brackets on the left hand side, that's T cold TH, and then plus T cold delta T, and then minus T hot delta T, and then minus delta T squared, and that's less than T cold TH. So we can cancel out T cold TH on both sides. And now we're going to have to check what we are getting. So we've got this here. So if I factorize a delta T, we have delta T times T cold minus TH, and then minus delta T is less than 0. So is this true? Well, let's see. So we know delta T is positive, right? But this quantity here if you think about it, it's actually negative, right? Because one obvious thing that we haven't specified, because it's obvious, is that T cold is less than T hot. Okay, so if we subtract both sides by T hot, we have T cold minus T hot is less than 0, right? So this here is already less than 0. And if we subtract even more, if we subtract delta T, it's going to be even more negative. So clearly what's in the bracket is negative. So we have something which is positive times something which is negative will be actually negative. So it means our initial assumption was true. And our initial assumption, remember, was the fact that eta 1 was greater than eta 2. And that corresponds to the fact that we decrease the cold temperature by delta T. So if you have a Carnot cycle, and if you try to improve the efficiency, and you have two ways of doing it, either by decreasing the cold temperature by a certain amount, or by increasing the hot temperature by the same amount, you will get a better efficiency if you actually apply that change in temperature purely to the cold source. And that's the end of the question.